Okay guys, so today I'm going to do a long requested one on sine, cosine and tangent ratios. So that's a part of trigonometry in maths at both junior cert and leaving cert level. So essentially what these ratios are is it's comparing sides of a triangle. Okay, so you're comparing the sides of the triangle, and so you've got an angle, so that's like your angle A or X or theta or whatever, and you've got your opposite side, your adjacent side, and your hypotenuse. So remember, hypotenuse is the side opposite to the right angle, so it's the longest side. All right, and essentially sine, cosine, and tangent, they are just ways of comparing the sides of the triangles. So sine A is the opposite over the hypotenuse, so opposite over hypotenuse. Then we have got the cosine of A is adjacent over hypotenuse, that's the one beside it, over the hypotenuse. And then the tangent of A is the opposite over the adjacent. So that has turned black, but essentially you can see there how they all work out like that. So as we work this out, you just got to notice it's the opposite and adjacent side to A, or to your angle. So for example, if we look at these two triangles down below here, we've got A, so over here is the opposite, over here is the adjacent, leaving the long one to be the hypotenuse. Again, you've just got to look at the other side, it's the opposite, the adjacent, and the hypotenuse. And when I'm doing them, I might just write OA and H for convenience sake. But it's just to note that it's the opposite side to A. It doesn't matter what way the triangle is laid out. So here, very simply, we can just figure out some of these ratios while we are going along here. So each of them, right angle triangles, the lengths of the sides are shown and the angles are labelled. To complete the tables below, writing the answers as fractions. So the way that we remember it, before we just jump right into it. So we know sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So sometimes when you write them out, they are written as SOHCAHTOA, or the way I have it up there. So we're going to use this to help us in all of these questions, this SOHCAHTOA, as I'm sure you have heard in class plenty of times. So sine A, let's first label them as opposite, adjacent, hypotenuse for A. And let's do this. So sine A, we have 4 over 5, opposite of our hypotenuse. Cosine of A then, we have got the adjacent over the hypotenuse, so that will be 3 over 5, and the tangent of A will be 4 over 3. Okay, we're going to do the same for the next one, adjacent, opposite, hypotenuse, and I'll just do it on the last one. We've got adjacent, opposite, and hypotenuse. Okay, so we'll just do it. So that's cosine B, so let's just stick with A for a start. Opposite over hypotenuse, so we've got 15 over 17. Cos is adjacent over hypotenuse, so 8 over 17, and we know that the last one's 15 over 8. And the third one, opposite over hypotenuse, so root 3 over 2. Then we've got 1 over 2, and then we'll have root 3 over 1, or just root 3 is grand because it's over 1. Now, that's for the A. Now we need to do the same thing for B. So we'll get rid of them, and let's do it the other way. So we've got the opposite, the adjacent, and the hypotenuse. So actually, hypotenuse will always be the same, but your opposite and adjacent will switch around when you're looking at these. So we'll do it the same method. So we've got 3 over 5, opposite over hypotenuse. Now adjacent over hypotenuse, 4 over 5, and opposite over adjacent, 3 over 4 for the first one. Second one, we need the sine, so opposite over hypotenuse, 8 over 17, then opposite over adjacent, 8 over 15. And finally, opposite over hypotenuse, a half, and opposite over adjacent is 1 over root 3. So you can see in these triangles, you're using the same numbers, but depending on which angle you're using, it becomes a different one that you need to look at. So the big thing to remember as we're going forward now is this SOHCAHTOA way of doing things. Right, so just to note before we go into solving some of these triangles that these are on page 13 of the formula book. There's these special triangles, these special angles, these 30, 45 and 60 degree angles. Especially at higher level you can be asked about these. But essentially what you've got to do they give you your values down here for special values of 30, 45, and 60. Now, the other thing is that you've got this thing called degrees and radians on your calculator. So we're not really going to go into radians here. You can translate them by doing this, multiplying them that way. But just to make sure that your calculator is in the correct thing, degrees or radians. Okay, so I'm just going to work with degrees in this video. So just make sure that your calculator has a little D up at the top. That's if you're using a Casio anyway, which I presume you are. There's a lot more to look at on this with, you know, these other sorts of things here. Don't need to worry about them for this video, but just to know that you can be asked to do things without using a calculator with 30, 45, and 60. So these special triangles, it's the whole, you know, 1 over root 2. So that's these ones in the 45-degree triangle. Then this one is 1, 2, and root 3. So they're just special triangles. Just note that they are there in the formula book. Okay, and also the SOHCAHTOA is in the formula book as well. It's just over the page. On the next one, you can see it, but the easiest thing is to remember SOHCAHTOA. It's there along with Pythagoras' theorem. Okay, so let's just get down to this now. Is just simply using your calculator. So to make sure that your calculator is in the right thing, make sure it's in degrees. So make sure it's in degrees and the little D on the top of your calculator. And literally, you can just put in sine 51, cos 73, tan 47. So just take a second and do that and make sure you get the right answers. I'll just give them to you here now. So this is what you should have got for 1 and for 2. And for 3. So if you've got those right, your calculator's in the right mode. Now, you can just be asked at leave insert level in degrees and minutes. So it's like a way of being more precise with your angles. So there's a little button on your calculator that kind of looks a bit like that. It's on the Casios anyway, it's kind of in the middle at the top. But depending on the model. But essentially you just type it in the exact same way, so just make sure you've got it right. I'm just doing these at 3 decimal places. If you just type them in degrees and minutes, you should get that. So make sure your calculators are right. It's very easy to just calculate straight off. And at junior cert level, you can be asked just to calculate straight off, especially at junior cert ordinary level. You might just be asked to use your calculator to find sine 51. So make sure you are able to use your calculator to do that. But what is more likely then is that you're doing it the other way around. So you're given a sine or a cosine or a tangent, and you have to find the angle. Okay, so here what we've got is we have cos theta, so theta is generally the thing used for an angle, is 0.7835. So we need to use the inverse trigonometric identity to have that when you're given it. So if cos theta is this, theta is cos inverse, or cos minus 1 of 0.7835. Okay, the same way here, tan p is this. So p is tan minus 1 of 2.4532. Again, I'm sure you can imagine, is sine q. So q equals sine minus 1, 0.6528. And I see below me there, I didn't rub that one out, but I'll just leave it there. Okay, so essentially you just put this into your calculators. So theta is, for this one, you should get 38.42. Then you do tan minus 1. I probably should have pointed out as well that this minus 1 is generally shift and then your sine or whatever. So it's generally the shift button you have to use up at the top left. And then tan minus 1, this should get you 67.82 degrees. And the last one should have got you 40.75 degrees. So again, very straightforward, but just know if you're given it straight, you just put it in. But if you're given it the other way around, you need to use the minus 1 button. So it doesn't matter whether it's written as theta or p or angle something or another, it's all the same. So just take a second, you can try 12 and 13 there. I'll rub them out. So you should have got, using the same method, you get sine minus 1 1/3. So also it doesn't matter if it's a fraction, you just put it in as a fraction, you get 19.47. And cos minus 1 of 2/5, you get 66.42. The same going over there. So make sure you know whether to use the normal sine or the sine inverse, or cos or tan as well. Okay, so just a little one to note here, I'll just leave them up there, is if you've got like something in front of your tan here, so 4 tan A. So it's very straightforward. if something's multiplying, you just divide by 4 on each side. So you'll get tan A equals 3 over 4. So obviously A equals tan minus 1, 3 over 4. So when you put that into your calculator, you will get 36.87. So 36.87 degrees. So if you have something in front of the tan, you want tan on its own before you can do the minus 1. You have to divide by 4 first. So you can try 16 and 17 there. Make sure you did it right. So divide by 5 on the first one, and you'll get a fifth, 1/5 there, 11.54, and of course you'll divide by 3 here on this one, and you will get that there. So very straightforward when you're messing around with these identities. You just need to make sure you use the right one each time. So let's move on to what really comes up in the exams, is solving these right angle triangles. So if you want to maybe take a screenshot or something of this, it can be helpful. So if you're using sine, you're using opposite and hypotenuse. So we know that, SOH, we always use that. Or if you have the O and H, you do the minus 1. Again, cos is AH, adjacent and hypotenuse, or the minus 1, and tan is OA, so opposite over adjacent. So make sure you always label your sides. That's probably the key thing you need to do, is label sides as you're doing these. So first of all, let's do some questions where you have all the sides. Okay, first thing you need to do in any question is label them. This is opposite and adjacent. Here, again, we're going to look over here. We've got opposite, and the long one this time, hypotenuse. And this time we've got to go, so that's opposite. So this is adjacent, and this is hypotenuse. And let's always remember SOHCAHTOA. So we got to keep them all in order. So we've got opposite and adjacent. So that means we're going to need to use tan theta equals 3 over 2. So theta is tan minus 1, 3 over 2. And that will give us 56.3 degrees. So you just decide which one you're using. So this time we've got opposite and hypotenuse. So this means we're going to need to use sine A equals 6 over 7. And then we're going to need to do sine minus 1. So A is sine minus 1, 6 over 7. And that will give us, it'll give us 58.99, but that will just round to 59 degrees because it's to the nearest degree. Oh, it's also the nearest degree. That's just 56 then. And finally, we will do this one. So this time we have A and H. So this means we're going to use cos B equals 9 over 11. So we do B equals cos minus 1, 9 over 11. And this will give us 35 degrees. So identify them and figure them out. So I'm just going to zoom out here and give you the next few. So if you want to pause it and try them, I'll rub out my white bits then. Okay. Right, so I'll rub that out. So you should have used sine, so it should be opposite and hypotenuse there. I'll just label these as well. So again, you've got opposite and adjacent here, and we've got a hypotenuse and adjacent here. So we've got tan here, opposite and adjacent. So we should have cos here as well. So that's how you work out these ones. Now, as we move on now, let's try some ones where we are not given both sides. So we're given one side, one angle. So, same as before, in every question we've got our angle. So this is our opposite, this is our hypotenuse. Do the same in this question. We've got our opposite and hypotenuse, and here got our opposite and hypotenuse. Okay, so it just so happens all of these are opposite and hypotenuse. So this is all going to be sine that we're using in this question. Okay, let's set it up as normal. So we've got sine 33 equals x over 7. Now, as we can see, it's not that simple. We can't just stick it into the calculator, but we want to get x on its own. So if we just multiply by 7 here, these will cancel out. And if we multiply by 7 here, that's the same. So we multiply 7 by both sides. So what you can put into your calculator is 7 sine 33 is equal to x. Obviously, you just put this bit into your calculator. You get 7 sine 33, and you'll get 3.8 equals x. So we just need to set them up correctly, and then they'll work themselves out. So again, here we've got sine 42 equals y over 15. So if we times by 15, we will get 15 sine 42 equals y. So 15 sine 42 works out as 10.04 equals y. It says one decimal place, always read it carefully, so it'll just be 10 equals y. So that's one decimal place. And lastly, we will have sine 58 equals z over 12. So what do? We multiply by 12 on both sides, of course. So we get 12 sine 58 equals z. And so 12 sine 58 works out as 10.2 equals z. So when the number's on the bottom, and obviously if it was a cos or a tan with the number on the bottom, you just multiply by it. So same idea if it was a cos or a tan. Now, if we go on down here now, it's slightly more complicated. Okay, so let's label our sides as before. We're finding the hypotenuse, but if you notice the hypotenuse as we're doing these, let's just put up our thing, SOHCAHTOA. As we've noticed many times before, the hypotenuse is on the bottom. So let's label them again, opposite and hypotenuse. Again, here we've got adjacent and hypotenuse, and here we have opposite and hypotenuse. All right, let's just set it up as normal. So we've got opposite and hypotenuse, so sine 42 equals 8 over x. Now, a little bit of a problem here because we can't just do a straight multiplication, but we still, to get rid of the bottom of this, we still want to multiply it by x, multiply this by x. That will get rid of these on the bottom here. So we have now x sine 42 equals 8. Now we want to get x on its own, so we'll divide by sine 42. Divide by sine 42, and that will give us our x. Okay, so x equals, it'll be 11.96, I think. Yeah, it says to one decimal place actually, so that will just be equal to 12 when you round it up. Okay, so what you need to do here in practice, I showed all my work there, which you should do, but you see what you actually end up doing is you've got the number on the top divided by the sign on the bottom. Okay, orange wasn't the right color to use there. So in practice, you can kind of skip one step. So let's just show you on the next one. So cos 51 equals 10 over x. So rather than doing all this multiply by x and everything, we know that x is going to be 10 over cos 51. Okay, so we do 10 over cos 51 just on your calculator. Now, just to note, on the calculator, you need to put these in brackets on the bottom here. Okay, I'll get rid of that highlighting bit there. You need to put it in brackets, or otherwise it'll say syntax error. So you get x equals 15.9. So when the letter's on the bottom, you divide the two numbers. When the letter's on the top, you multiply them. And lastly, we've got opposite and hypotenuse. So we've got sine 73 equals 18 over x. So what it'll be when we do the next thing is 18 over sine 73. Make sure to put them in brackets in the calculator, and you'll get x equals 18.8. So solving these right angle triangles, I'm just going to zoom out so we can see them all. Might be a bit small. You can screenshot it if you want. So if you've got the number on the bottom of the fraction, you just multiply. It's nice and easy. And if the number is on the top here, you will divide. Okay, so if the number's on the bottom, therefore the letter on the top, obviously, and this is the letter on the bottom. The number on top, you're going to divide. So that's just how you'll remember that. The letters on the top, you're just going to multiply like here, and if the letter's on the bottom, you're going to divide like down here. Okay, let's move on now to a couple of slightly more difficult questions. So a lot of the time what they'll do in an exam is they'll put things as like double triangles and stuff like that. So you just need to do one triangle at a time. And what's a good practice in this is to draw the triangle that you're using. So this one says, find the values of x and y correct to the nearest whole number. So first of all, we're going to look for x. So draw our triangle. We've got 62 here, 8 here, and x here. We just ignore the rest of it for now. let's label it adjacent and opposite. So we know that with adjacent and opposite, we're going to be using tan. So tan 62 equals x over 8. So we will just times by 8, and we will get what is equal to x. So we'll get x equal, so we'll get 15.5 is equal to x. Now I know it says, sorry, not 15.5, 15.05, I think. 15.05. Now, it says the nearest whole number, but I generally just do that at the end. So now we're going to try and do y. So again, now we've got the length of x, it's 15.05, and we've got y, and we've got 37. To do the same thing, we've got an opposite and an adjacent, so we're going to be using tan again. So we've got tan 37 equals 15.05 over y. So we see the way it's on the bottom this time. So we have y equals 15.05 over tan 37. So 15.05 over tan 37. That will give you 19.97. All right, so you can see they do work out nice enough, but it says the nearest whole number. So x is 15 and y equals 20. Okay, so you see, you just take it one triangle at a time, and then you're able to do it. Right, so I have two more. If you just make a point of pausing when I scroll down to it before I do it, and then I will do it out for you. So here's another one. So you can pause it and try this question now. Right, let's work with what we've got. So we've got the first triangle, we've got x, y, or we've got 13 and 12. Now, the only thing to note here is you've got no angle going on here. So generally, if there's no angle, that means you're going to have to use Pythagoras. So that's going to pop up just a little bit over the next wee while, is that you're going to need to use Pythagoras for some things. So remember, you can label them as CAB. So if you remember Pythagoras, there is c squared equals a squared plus b squared, or c equals root a squared plus b squared. Now, the only thing is with this one, c is the long side. So in order to get, so that's how to get a long side. To get a short side, you will do the square root of c squared minus either a squared or b squared. So just so that you know, it's Pythagoras that you need to be using here. What you're going to be doing is the square root of 13 squared minus 12 squared. So it's 169 minus 44. You'll get root 25, which is equal to 5. Okay, I'm going to have a bit too little space here. I'll try and move this down here as well. Right. Okay, so you've got 5 as your length y or. So this is y or. Right, that's that triangle done. But now on the other side, we are going to need to do some sine, cosine, tangent. So I just included that one to show that Pythagoras often pops up in these questions. Okay, so we've got a 30 and a 12. So we've got an opposite, we've got an adjacent, and we're looking for a hypotenuse. So let's just move this boy over here. Okay, so let's get the adjacent first. So we've got the opposite of equation, so we've got tan 30 equals 12 over a. So a equals 12 over tan 30. Okay, and so that length, we should just label these as well. We've got the length or z, that will give you 12 root 3. Okay, and you see where it's saying find the perimeter plus b root c, so you know that that's going to be correct. Okay, we also need to find the hypotenuse though, so we can use sine 30. So often you'd have to use the same thing twice. So sine 30 equals 12 over h. So h equals 12 over sine 30. So 12 over sine 30 is going to give us 24. So we've got all of our lengths now. We can fill them in. So we've got 5, 12 root 3, and 24 now as well. Right, look what it says for you to do though. Find the perimeter of the triangle. So let's get our perimeter. We will do 13 plus 5 plus 12 root 3 plus 24. So add your numbers. 13 and 5 is 18 plus 24 is 42. So 42 plus 12 square root 3. Okay, and that's the answer. So it's in the form a plus b root c. So that was a slightly trickier question where you had to do something extra at the end. But again, you're just using your trigonometry skills to do it. Okay, got a couple more for you to do before we finish up for this one. I will make a second video with some exam questions, but I'm thinking based on time that I've done enough for this one for now. So in the given triangle, find x, but do pause it and try it yourself first. X correct to 1 decimal place and a correct to the nearest degree. So first of all, again, draw the triangle you need, 68x. So we have got an adjacent and an opposite. So that means we're going to be using tan 60 equals x over 8. So it'll just be a times 8 we need to do here. So 8 tan 60 is x. So x is equal to 4 root 3. Okay, and you're told to do it correct to 1 decimal place. So 4 root 3 to 1 decimal place is 6.9 is equal to x. All right, now we've got that done. Let's do our other triangle. So you draw it out, and we've got a. I'm just going to leave it as 4 root 3 here, and we're going to use 20. Okay, let's label them. We've got an opposite, we've got a hypotenuse. So we will use sine a equals 4 root 3 over 20. Okay, and so remember, we will do now a equals sine minus 1, 4 root 3 over 20. Okay, so we get sine minus 1, 4 root 3 over 20. And that will give us 20.27 right there. So you can see you're using a mix of things here. Let's say so the angle to the nearest degree, so that's just 20 degrees. You can see that you're using with x on the top multiplying by 8, and you're using the minus 1. So again, questions are often a mix of these things. Okay, so just to finish up, a couple of real life kind of questions. So pause the video and try each one as we go through it. They're not too difficult, but these are the kind of things that come up. So one of them is heights of things. So it's like the angle of elevation of the sun. They often put that in exam questions. An upright flagpole casts a shadow of length 18 meters. Calculate the height of the pole. Now, I know it says real life problems. I don't think anyone is ever going to do this in real life, but it is what it is. You just turn it into a triangle. You've got a triangle to solve. Don't worry about the sun and the pole. You've got 18, you've got 15, and you've got the pole. We'll call it P for pole. I'll not call it H because that confuses things with hypotenuse. Okay, so you've got the adjacent, you've got the opposite, and you've got the hypotenuse. Hypotenuse isn't relevant, so we just need opposite and adjacent. So that means we're going to use tan 15 equals P over 18. Okay, and so 18 is on the bottom, so let's multiply by 18. So we've got 18 tan 15 equals P. So we will have P equals 36 minus 18 root 3. Okay, so obviously that is an awkward number. It says to 1 decimal place, so that will give us 4.8 if you just press the SD button. 4.8 meters is the height of the pole. So it's literally just a triangle that's like this. Okay, that's all it is. You just make the triangle. Don't worry about the sun and the pole. Just make a triangle. Okay, 2 more just to finish off. Okay, top of a wall. They sometimes talk about ladders as well. But this, so the distance from the point P on top of a wall, that's up there, is 24 meters to the ground. And the angle of elevation is 29. Again, this is just a matter of a triangle. We've got 29. H, I don't like using H's in this, but we'll just work with it. Okay, so we've got our adjacent. This is really our opposite, and this is our hypotenuse. So I'll just use the full things here just to be sure. So we don't need the adjacent, it's not relevant. So we've got the opposite and the hypotenuse. So we have tan again, so tan 29. No, that's not tan, it'll be cos 29. It's not actually, it's sine 29. I'm getting tired talking for too long. Equals h over 24. So it's just a matter of multiplying by 24. So we've got 24 sine 29 equals h. So we do 24 sine 29 is 11.64. 0.64 equals h. Okay, and that's in meters, of course. Make sure to put your signs in. And one final one is one with a double triangle here. So Sophie is standing 5 meters from a tree. From her eye level, the angle of depression at the base of the tree is 19 degrees, and the angle of elevation is 64. Again, doesn't really matter. Just make it your two triangles. So how tall is the tree? So you've got this height and the bottom height. Okay, so you're just going to have to do the same thing twice on two different triangles. Okay, so let's start with our top triangle. We've got 5 meters, 64 degrees, and this is our side that we want to find. We'll just call it x. Okay, again, adjacent and opposite. So we've got tan 64 equals x over 5. So we're going to have 5 tan 64 equals x. So x is equal to 10.25. So let's do the exact same thing then with Sophie at the bottom of the tree. So we've got length of 5, 19 here. Again, it's going to be your adjacent and your opposite. It doesn't really matter. So we've got tan 19 equals, we'll just call it y for the sake of it, y over 19, y over 5, sorry. Times it by 5, we will get 5 tan 19 is equal to y. So let's have y equal to 1.72. So the height of the tree, so the height of the tree is 10.25 plus 1.72. So 10.25 plus 1.72 is 11.97 meters. 7 meters. So it says to the nearest meter, and it is 12 meters. Okay, so just to finish up, then we will get, so it says use the information to estimate Sophie's height given your answer to the nearest centimeter. So Sophie's height is around the height at the bottom, but slightly more, so it's just over 1.72. So about 1.8 meters is that there. And to accurately calculate it, we'll just finish off with that, is accurately calculate it is just, you'd need the height of her forehead as well. So she's probably about that. Anyway, that will do for this one here. And we can leave it at that. I will follow up with an exam questions one. I have been talking for over half an hour, so I think that will do us. Good job.